All right, welcome back and to this, our continuation of our section on less frequently encountered Oracle concepts. In particular, in this lecture, we are going to cover collections. Now, when last we met, we ended in a rather odd place, and I'm sure many of you felt a little hung, if you will, as to where we ended. We had introduced the concept of nested tables, but never really got into how to manage these things, how to do DML on these guys. Well, that's my fault. My apologies, but it was my opinion that this particular collections lecture was going to run too long. Udemy only gives me a maximum of 20 minutes per lecture, and it was my expectation that this collections lecture was going to run longer than that. As such, I needed to make some, if you will, outline modifications, and that's why you guys saw an introduction to nested tables within the last lecture, where, quite frankly, it didn't belong because it's clearly a collection. My apologies for that, and if it caused you any angst, again, I'm sorry, but I got to play by the rules as well. All right, let's take a look at V-arrays, nested tables, and associative arrays. Remembering that associative arrays used to be referred to as indexed by tables. And that'll make some sense as we go forward. But for now, let's go ahead and open up that script file, get developer fired up, and let's look at some code.
All right, before we get started back in the heavy stuff, I'd like to do a little schema cleanup here. Now, we all know every good programmer and database person just a little bit OCD'd. You know, we're kind of compulsed to keep learning those new languages while balancing that with our outside lives. That being said, I'm afraid at this point we've left our schema rather untidy, and I'm a little embarrassed by it. We actually have a table out there named Better OB Customers. Come on, Rick, that simply cannot stand. As such, please do me a favor and run those couple of DDL commands at the top of your script and blow away those unused objects and tables, and then rename that Better OB Customers table to simply OB Customers. All right, we're going to start working with that guy again, so please do a describe on him so we can recall exactly how he's constructed. Oh yeah, I remember now. We have a standard customer ID field, a pointer to an object person type, and then two nested tables, one for addresses and another for phone numbers. Oh, cool. This looks like it's going to play nicely. Okay, we begin messing with our OB Customers table by inserting a new row as shown here in this syntax. Insert into OB Customers and then our list of field names. Certainly nothing surprising there. Next we have our values keyword followed by a comma separated list of values. Looks like we're going to assign this row a customer ID of 1. That's fine. Next, as we learned in our last lecture, to set a pointer, we need to ref a row in the persons table. Okay, and I remember having done that. Now, time for our embedded tables. We start by setting our current addresses, which are of type nested address, so we need to use that nested address constructor. Follow that guy by a comma-separated list of those object types. In our case, that object type is object address, so each row needs that constructor followed by the appropriate list of fields. Yeah, that makes sense. Now we do the same game for phone numbers. Current phone number field made up of nested phone number type, which in turn is made up of the object phone number type. Just a thing to remember here on the syntax is get those constructors right and in the correct place. All right, let's compare that syntax to our next insert where our current phones field is being set to null. Yeah, okay, I can see that. Finally, how about this third insert statement? Here we're setting our pointer to a null row and our current addresses field to a null nested table. Again, I think once you think about it, it all seems pretty darn reasonable. All right, before we look at update statements, let's retrieve our OB customers row and make certain that what we think we stuck in there is really in there. All right, let's go ahead and try it in Developer, but trust me, guys, it's not going to work. All you're going to get is those stupid object types. I don't know why they can't make that thing work. Anyway, I'm interested in the deref values, so off to SQL Plus we go again. Here's the result for where customer ID equals 1. Nice. Customer ID 1 as expected. Then check out this OID, object reference, the address of the object being pointed to by our person ref field. You could actually take that guy and follow him down and point to that field, or that row rather. Next is our nested address field, and it's 3 object address rows. Good. Finally comes our nested phone number field, and it's 2 object phone numbers. Sweet. Just what we expected. Why Developer couldn't do that, I'm not sure, but I'll get over it, I guess. Now let's do an update. We'll start by adding a row to our current addresses collection for customer ID equals 1. First off, check out how we used an inline view here as our select. In fact, we're selecting the current address field of the OBs table where our customer ID equals 1. All right, that's now our table that will be doing the insert of a new object address constructor. Hey, come on. Somebody had a pretty good day at Oracle when they thought up that syntax. That is truly elegant. In this next update example, we again use our inline view to establish that we will be updating, and in this case, the current phones nested table of the OB customers table, where the customer ID equals 3. We then use that table alias to select and then set the values of a specific row in that nested table. Again, very cool use of an inline view, but probably not as elegant as the method directly above. Can you imagine having to do 1,000 of those updates? Not very cool. Better set yourself up a PLS package in that case. Okay, probably not real hard to guess where we're going to go next. Delete statement. Here's the syntax, which should be getting a little more familiar at this point. Again, we're using that inline view to select the current phones nested table from the OB customers table where customer ID equals 3. Give that guy a table alias and then use that alias with the values keyword in the where clause. Again, pretty straightforward once you start using this inline view syntax. Pretty intuitive, actually. All right, before we wrap this lecture up, I want to talk briefly about 2 additional collection types. V-arrays and associative arrays. Associative arrays used to be called index by tables when I was still in the business. We'll start with V-arrays. V-arrays are to nested tables as a Model T is to Mercedes-Benz. V-arrays store an ordered set of elements. Those elements may be of standard Oracle type or user-defined. Net, these guys correlate exactly to what we think of as a standard array in a 3GL. Good news, just like in a 3GL, those array indices make great loop control variables. Bad news, the Oracle implementation of V-arrays doesn't allow you to update a single element of the array. You got to update the entire stack. Are you kidding me? You need to update the entire collection? Yuck. Net, I think they are absolutely useless in their current configuration, and besides, why would you simply not use a nested table? Again, Model T, Mercedes-Benz, I'm going to use the Mercedes-Benz. Now, bad news. A V-array's max index has to be set when you create it. Good news, you can increase it later. Why? Because they're stored in line with the regular row elements for that table. Bad news, what does that actually mean? Donald Burleson, probably the best Oracle performance guy I know of, thinks these guys may be of a huge performance problem. Hey, if Burleson tends to think these guys are a problem, I'm staying away. All right, moving on to our last collection type, associative arrays. Associative arrays are nothing more than tuples available to PLSQL, short-term storage. You pair a key and a value. The key used to be restricted to an integer, and as such, these things used to be called indexed by integer tables. As of Oracle v10, the key can be any standard Oracle type. The value, of course, can be user-defined and or Oracle type, doesn't matter. Net. If you're required to maintain some old PLSQL code, it's entirely probable you're going to run across these things as a method for temporary storage. We used to define them as records and then create a table of those records indexed by integer. Would I use them today in any PLSQL package? Probably not. I'd use user-defined types instead. They're just a whole lot more flexible. And what's the important point here? You got to know this one for the cert exam, so put it to memory, guys.
Hey, you know what? That was fun. I enjoyed that. And by the way, you know what? I went and looked back at our chapter or our lecture on packages, and sure enough, I had used the index by table construct there. Obviously should have used user defines in a nested table, but, you know, even good old Rick sometimes forgets, so I apologize for that. But as I suggested, most of what you're going to do with respect to associative arrays anyway is going to be maintaining the older stuff, because today we'd simply create a table of user defines and that'd be enough for us to work with. All right, quick little review before we move on. We began with a discussion of how to insert records into a nested table. Remember the use of our constructors. Then we did an update to a nested table wherein in fact we added an additional row to that nested table, implemented as an insert. And remember our use of those inline views to select the particular rows to be updated within that nested table. A very good use of an inline view, one of the few that I can actually think of. We then did a true update of a row in a nested table, again utilizing the inline view, but now using the values with the table alias to specify our list of new values, as well as the values table alias to specify the old values in our where clause. Pretty straightforward syntax once you got your hand around it. Finally, we were able to delete a row from a nested table, again using the inline view strategy to identify those rows to be deleted, and then the values table alias in the where clause to again filter those rows out. Pretty straightforward stuff. We then went on to discuss V-arrays and associative arrays. Quite frankly, I'm not sure why you'd be using these other than if you're more comfortable with an array concept because of your 3GL background. But please understand, V-arrays do not perform as well as do nested tables, so be careful there. As to associative arrays, these guys used to be called index by tables, and so any of you who are required to maintain PLSQL code that was, let's say, more than 5 years old, you're going to encounter that construct there. Pretty straightforward stuff, no real big deal. All right, that pretty much concludes our discussion of collections. In our next lecture, we are going to start looking at large objects. Yes, the bane of every database designer's existence, large objects. What do I do with these things, and why are they so bloody darn important? Okay, until then, you guys will go out there and have some fun, but remember, learn something new every day.